The curve C is defined by this here, and we've got a point 1, 2 and lies on the curve. So find the equation of the normal to C at this point P. Well, notice again we've got the product. We've taken away the product of 5xy squared. So let's just look at 5xy squared to start with. So u will equal to the 5x, v will equal to the y squared. So du dx, u dash will be 5, okay. We differentiate that, and dv dx, v dash will be 2y dy dx. Okay, so then the product will be v du dx, so that times this, so y squared times 5 plus u times dv dx, which is 2y dy dx. Okay, so there's a bit to tidy up there, but we'll sort that out now in a minute. So then when it comes to differentiating this, well, 3x cubed becomes 9x squared. And remember then we've taken away this product, so we've taken away that. So you've taken away 5y squared, and you've taken away this, and that becomes 10, doesn't it? 10xy. So taking away 10xy dy dx. And then you've got to differentiate this as well, so that becomes 8y cubed dy dx. Okay, and of course 15 then just becomes 0. Okay, so you look at each term, is there any common factors here? Okay, so you could divide through to make life a little bit easier, and there's nothing there. And then also look at the question, ask you know, do we need to find an expression for dy dx? And actually we don't, we just need to focus on this particular point 1, 2 here. So what I can do now is substitute that in, so to work out what dy dx is. So I can say, look, at 1, 2, okay, well, let's sub it in. So we've got 9 times 1 squared, take away 5 times 2 squared, take away 10 times 1 times 2, x is 1, y is 2, dy dx, plus 8 times 2 cubed, dy dx equals to 0. So this will be 9, that will be 20. 10 times 1 times 2 is also 20, so dy dx then. And 8 times 2 cubed is 64. So we get that. So we've got minus 20 plus 64 is 44. Dy dx. 9 minus 20 is minus 11. So take it over the other side, becomes 11. So that means that dy dx will equal to 11 over 44, which actually works out nicely to be a quarter. Now remember, right, that will be the gradient of the tangent. So the gradient of the tangent is equal to 1/4, but we want the, remember it says we want the equation of the normal. So to get the equation of the normal, I need the gradient of the tangent, don't I? Of the normal rather. Now I've got the gradient of the tangent, worked it out by doing dy dx. Can I get the gradient of the normal? Well, remember the result, m1, m2 is minus 1. Okay, well, if I know one of the gradients, which I do to be a quarter, I can work out the other gradient by using that formula. So I know the gradient of the tangent. I now need to work out the gradient of the normal. So I've got quarter times m2 is minus 1. So take that quarter over the other side and divide by it. When you've got a fraction at the bottom, the number flips up, so you get minus 4. So the gradient of the normal is minus 4. And all we want then is we want the equation of the normal at the point 1, 2. Okay? And of course we know the gradient is minus 4. So we use the formula, y minus y1 is mx minus x1. So it'll be y minus 2 equals minus 4x minus 1. So y minus 2 is minus 4x plus 4. So that means then you get 4x plus y minus 6 equals to 0.